Hello, I'm an alien. You can call me Al. This is part 2 of my message about the capture of other carbon emissions. Here is a diagram of the carbon cycle. The big yellow numbers are natural flows and the small red numbers are human-based flows. In round numbers, the human stuff is 9 out of 129 units, being 7%. In other words, natural emissions are 93%. So, carbon emissions basically consist of carbon dioxide and methane. Of these two, the methane is considerably more potent, but significantly rarer in the atmosphere because it soon breaks down to make more carbon dioxide. So these two gases are closely related. If you capture methane, you save a lot of carbon dioxide and heat. Here's the equation. CH4 plus 2O2 equals CO2 plus 2H2O plus heat. Methane is generated naturally within the Earth by various microbes, and it makes its way to the surface where it enters the atmosphere and helps to keep the Earth warm. However, at present, you have too much in the atmosphere. So now why not retain some of these natural emissions? Generally, gas emerging under the land is too dispersed to capture efficiently. However, beneath the ocean is quite different. Vast columns of methane are produced by subsea volcanic systems, where a tethered underwater machine could harvest them and lock them up as hydrate boulders on the seabed. Here is a sketch of such a machine. The hot, rich methane plume is captured just above its source, and the bubble stream allowed to rise within a gas lift chamber. This consists of a vertical pipe containing bubble-breaking chains designed to ensure maximum gas-water mixing. The gas also cools as it expands, so that by the time it reaches the top of the chamber, it's either dissolved or formed hydrate crystals. Due to the relative density of the gas-water column, the internal pressure is considerably higher than the surrounding ocean. This is the gas lift effect. This excess pressure is then used to pump the mixture sideways and downwards to arrive some kilometers away from the vent zone at a seabed location of relative inactivity. During this transit, further cooling takes place. Sand from the seabed is injected to increase density of the deposit and ensure that the hydrate is negatively buoyant when the mixture is released. The hydrate crystals form boulders which are relatively stable on the ocean bottom for hundreds of years. Here are the numbers. A typical column of gas contains the annual equivalent of 5 million car exhausts. It's estimated that the oceans contain upwards of 32,000 seamounts. Harvesting only 1% of these would balance your carbon budget until such a time as you manage to reduce human emissions. It should be noted that these machines float well above the vent mouth, so do not impact the vent organisms. Here is a last thought. By harvesting such other carbon sources, you can not only compensate for human emissions, but also start to reduce the levels back to pre-industrial intensity if you so desire. Developing this technology would enable you to stabilize your world indefinitely.